Good morning and welcome to the first episode of Ahargana. I'm standing here on the banks of the Kaveri. It's about 10:30 in the morning. The sun is rather mild, though it's the middle of April. It's a somewhat cloudy day. Quiet flows the Kaveri by my side. I can hear some birds chirping. I think you can hear it too because my microphone is picking up that sound. And upstream there are some rocks and a little bit of rapids, so Kaveri is not as quiet as I said just now. I can hear a little bit of the rumbling on the rapids. There's a very gentle breeze blowing, rustling the waters around me. It's lovely to be out here. But I'm not here to talk about the Kaveri and about the birds and about the wind and about nature. I'm here to talk about something else which is not on this scale of nature. I'm here to talk about nature on a much grander scale. The topic of this series of videos is the Hindu calendar, or more specifically, it's the astronomy behind the Hindu calendar, the astronomy which forms the basis for the Hindu calendar. Now, all of us follow a civil calendar which has got 12 months, January, February, March, April, etc., etc. 30 days, 31 days alternating. February has 28 days, 29 days on a leap year, etc., etc. The only astronomical basis for that is the fact that the Earth goes around the Sun in 365 days, and that forms a year. Apart from that, everything else is somewhat arbitrary, fixing 30, 31 days, 29 days, 28 days in order to adjust the whole year to come to 365 days. Which is fine. I mean, it is what it is. But I hear many youngsters always complaining to me, why is it that our festivals, our Hindu festivals, never fall on the same day year after year? Why do the dates of these festivals keep shifting every year? We have to look up the calendar. Sometimes Navratri falls in September, sometimes in October, sometimes Deepavali falls in October, sometimes even in November. And we have to keep chasing, trying to find out, look at the calendar and find out when these festivals happen. Why is this so? Now I tell them, I mean, it's obvious. You are following a Christian calendar, whereas our Hindu festivals are Hindu festivals. So you're taking Hindu festivals and looking at a Christian calendar and you're complaining that they're not matching. Why are you surprised? If you look at a Hindu calendar, then these festivals will happen on the same month, same date, year after year after year. Now that leads to the question, then what is the Hindu calendar? Yeah, now Hindu calendar has a lot of elements. For example, you all know about Uttarayana, Dakshinayana, then Hindu calendar has various months, Chaitra, Vaishakha, Jyeshta, Ashada. Then there is Krishna Paksha, Shukla Paksha, there is Navami, Dashami, a lot of elements. But what are all these? In the Christian calendar, all we have is January, February, March, and you're done. And maybe days of the week, 7 days of the week. Whereas here, there are so many elements. What are all these? Nobody knows. Neither did I until about 10 years back. Now, somewhere around 10 years back, a colleague of mine called me one day in the morning and he said, Kishore, wish you a very happy Yugadi. So I wished him back. I told him, Dinesh, thank you very much. Wish you a very happy Yugadi too. But I am from Udupi and our Yugadi is on April 14th, not today. He called me sometime in March, towards late March. Then he said, oh, so you follow the Sauramana Yugadi. So that piqued my interest. So I asked him, okay, what is Sauramana? And he said, that I don't know. I know that there is Sauramana and Chandramana, two Yugadis, and they don't fall on the same day. They fall on different days. When we dropped this topic, we kept on discussing various other topics, about delivery, etc., etc. But this topic stayed in my mind. And I said, I need to find out what is this Sauramana and Chandramana. And there started my investigative journey to understand the Hindu calendar. And what I learned, what I found out, astounded me. Because the Hindu calendar is 200% based on astronomy. More specifically, the Hindu calendar is entirely based on the movement of two celestial bodies, the sun and the moon. Complete astronomy. And I thought to myself, and when I did this investigation 10 years back, I was past 50. I was an educated Hindu. Yeah, I have a bachelor's degree in engineering from a leading engineering institute in India. I have a master's degree in computer science from an American university. So I consider myself an educated Hindu, but I knew nothing about the Hindu calendar. So I said, this is not right. This is completely wrong. We should know about our Hindu calendar. This is our tradition. This is our calendar. It's been defined a long time back. In fact, 1600 years back, Surya Siddhanta is the basis for most of the things which I learned and understood about the Hindu calendar. So I started thinking, I need to spread this information. I need to spread this knowledge. And the result of that is this video series which I am preparing, Mahargana, and this is the first episode in this video series. My aim is to explain to people in this video series the astronomical basis of the Hindu calendar. And in doing so, in addition to just talking, I'm also going to use an astronomy software called Stellarium. Now, Stellarium is a modern day astronomy software. It has been developed by some East European or European academics. It's a brilliant software. And I have created animations using Stellarium to illustrate the various calendric elements of the Hindu calendar. And I will use those animations in the subsequent episodes, starting with this one, to explain the astronomical basis of the Hindu calendar. In this first episode, I'm going to introduce a fundamental basic concept of the astronomy behind the Hindu calendar, which is that the Hindu calendar is based on a geocentric model of the solar system. What does that mean? That means that the Hindu calendar assumes that the Earth is in the center of the solar system and the sun and the other planets go around it. In fact, it is a misnomer to call it a solar system because it is the Earth in the center. The source of what I am saying is the Surya Siddhanta. Now, that is an ancient Siddhanta, scientific treatise which has been written not earlier than 400 AD. Authorship of that treatise is unknown. Some people say Aryabhatta wrote it. Not very sure, but it is definitely 1600 years old. And according to the Surya Siddhanta, Brahma created Brahmanda, and put the Earth in the center, steady and unmoving. And the sun, the moon, and all the planets are going around the Earth. Now, you may say, hey, this is wrong, this is completely wrong. We all know sun is in the center, Earth is moving around the sun. So Surya Siddhanta is wrong, Hindu calendar is wrong. Hold your horses, it is not that simple. The Surya Siddhanta and the geocentric model, or rather the geocentric model, is an observed model. What does that mean? That means that you and me, we live on this Earth. I am standing here on the surface of the Earth, on the banks of the Kaveri. In fact, there is a mango tree out there, and last night, the moon beams were seeping through. Beautiful. But the point is, I'm standing here, you are standing on the surface of this Earth, and then we look up at the sky and we observe. And what do we see? We see everything is going around us, round and round and round. In fact, I am facing west, that is east, so everything is going around us like this from this point. That's what we observe standing on the surface of the earth. And that is what the geocentric model represents. Now, I use the term model, right? I didn't say geocentric reality. I said geocentric model because a model is a representation of reality. It does not claim to be reality. Now, if you and me were living on the surface of the sun, then it's a different matter. Yeah, we can see everything is revolving around the sun. We can observe it. But you would be fried if you go anywhere near the sun. So the geocentric model is an observed model, and it is meaningful because that's exactly what we see from the surface of the earth. And if it doesn't match reality, are you surprised? Because in Hindu philosophy, we know fully well, all of us know fully well, sab maya hai. What you see is not the reality. In fact, today morning I saw the sun rising in the east, somewhere there behind me, and it's come up and it's going to set out there in the west. And is that the reality? No, that is not the reality. The reality is the earth is spinning. Sun is moving, yeah, but it's moving so slowly. 365 days in the geocentric model it takes to go around the earth. But this 12-hour movement, sunrise to sunset, is Maya, because the earth is spinning and I feel the earth is stable. I don't feel any spin. So in astronomy, you will see a lot of such Maya happening. Yeah, the reality and what we observe are vastly different, because some of the planets and or stars you see in the night sky are so far away that it takes 50 light years for the light from that star to reach us. So if that light is reaching us today and I am seeing it, that light left that planet 50 years back. So today the planet may not even exist, that star may not even exist. We just see as it is, as it was in the past. So getting back to the basic point, geocentric model of the solar system is the foundation for this entire series. And as I already mentioned, I'm going to use Stellarium, an astronomy software, a planetarium software, if I may say so, to illustrate everything in this web series, including the geocentric model. And to repeat, Stellarium is a modern day software. It has been developed by European academics, and I am using a modern day software which is written today to illustrate the calendric concepts which are coming from Surya Siddhanta, which was written 1600 years back. So in effect, I am trying, using this web series, to build a bridge across 1600 years. So I'll stop my talking now. I'm going to show you an animation using Stellarium, which illustrates the geocentric model of the solar system. It will be your first look at Stellarium, and you will get a feel for what's going to happen in the rest of the web series as I start getting deeper and deeper. So I'm going to start the animation now. Take a look. Okay, let's get started. This is your first view of Stellarium, and this is typically how Stellarium starts off. It is displaying to you the location Bangalore, India, on 12th of April 2021 at 7 o'clock in the morning, and we are facing north. So towards your right, you can see a little bit of brightness on the horizon. So that is east, where the sun is rising, and west is to your left. Down below, it shows here that the location is Earth, Bangalore, 914 meters, field of view is 60 degrees. And up here on the top, you can see 2021, April 12th at 7 o'clock in the morning. But this view is not very interesting. A lot of it just the ground. It's a simulated ground. It's not really a Bangalore scene. I don't know if Bangalore really has any meadows like this anywhere at all. Maybe Cubbon Park. But It's not very interesting, but because very little of the sky is visible. So I'm going to start the animation now and get it moving. And the first step I'm going to do in the animation, which you can never do in real life, is to zoom out to get a larger field of view. Here goes. So stellarium is zoomed out. In reality, you can never do this. If you want east and west right in front of your eyes, it's impossible, because if you're facing north, you are facing north. East will be 90 degrees to your right, and west will be 90 degrees to your left. You have to turn your head 180 degrees to see east and west. But because Stellarium is a software, I can zoom out and get a large field of view, a 210-degree field of view, and show you east, west, and north on the same screen. So in the east, the sun has risen already at 7 o'clock in the morning. But this orange circle that you see is actually the moon, it's Chandra. You're able to see a little bit of Buddha also there, but we will talk more about that a little bit later. Now, the next step I'm going to do in the animation is, as time passes, I'm going to show you the Earth rotating. What does that mean? Take a look. So Stellarium is now simulating time, the passage of time and the movement of the horizon as time passes. So we started at 7 o'clock in the morning. Now we have reached 12:14, 14 minutes past noon. And you can see that the sun has come up in the sky. But in reality, what happened? What happened was that the horizon moved away from the sun. That's why the sun looks like it came up. Otherwise, you saw the sun was pretty much there in the same position. If this is 0 degrees, the sun was somewhere around 30 degrees. This is 60, this is 90. So the sun was pretty much a little bit short of 30 degrees. But it has still moved up so far because the horizon dropped away. Now, ideally, the sun should be overhead by 12 noon. It doesn't appear like that in this. So I'm going to reset this view a little bit. I'm going to recenter the view as follows. So now I brought 0 degrees to the left, 90 degrees right to the top. And now you can see pretty much, yeah, the sun is straight overhead, the noon sun. And this line, which is the meridian, is effectively showing you the sun is overhead. Now you can also see Guru and Shani. But as we move into the next step in the animation, things become more interesting, because I'm going to show you day and night. So far, everything is day. We moved from 7 a.m. to 12 noon. But now we start moving towards evening. So now you can see the horizon is coming up. So sun is going to set in the west. And as the sun sets in the west, that's twilight and night. The stars have come out. Some stars are big, some are small, some are spiky. But you can see the night sky simulated by stellarium. Now time is still ticking. Now we are 1 o'clock in the night, 2 o'clock in the night. But now I'm going to up the tempo a little bit and speed up time much faster. So as time starts speeding up, the clock is ticking faster and faster up on the left, and the earth starts spinning faster. And now the movement of Chandra is becoming extremely visible. You can clearly see the moon is moving. And you can begin to start seeing that Shukra and Buddha are also moving a little bit. But now when I increase the speed some more, faster and faster and faster, the movement of the sun, Buddha, Shukra, everything is clearly visible. And Chandra is also moving much faster now. And since we are interested in the movement of the sun and the moon, this is the kind of speed at which I want the simulation to run, so that I can illustrate the calendric elements. The next step in the animation is to remove the atmosphere. What does that mean?
This is what it means. Now I got rid of daytime because I want to see the celestial bodies all the time. So I removed the daylight from the picture. It's continuously night, everything is visible. And the next and important step is to get rid of the earth. Why do we want the earth? We don't want the earth, we want the sky. And that's what you are seeing now in front of your eyes. The distracting movement of the earth spinning on its axis has been removed from the picture. Now all the movements of the heavenly bodies are clearly visible to your eyes. And the final step is to get rid of the unnecessary stars from the picture, because the stars really do not contribute to calendric elements. And once the stars are removed, you have in front of you the geocentric model of the solar system. This is the basis on which the rest of this web series is going to operate. This is the model which I am going to use to illustrate the various calendric elements of the Hindu calendar going forward. Now you can clearly see in this picture 7 of the 9 Navagrahas. Of course, here you have Surya, sun, here is Chandra, moon, and here is the red planet Mangala. And down here is Buddha, which is Mercury. You can see on the top left, the names are shown. And here is Shukra, which is Venus. This, of course, is the beautiful Shanaishchara, Shani, the slow moving one. And this is the big gas giant Jupiter or Guru. So these are 7 of the 9 Navagrahas. The 2 more are Rahu and Ketu. But Rahu and Ketu are not physical bodies. They are just 2 points on the ecliptic. And hence stellarium cannot show you Rahu and Ketu. Now, I just used the term ecliptic just now. And that is an important concept, and I left it for last. The ecliptic is nothing but this green circle that you are seeing. It anchors this whole model. By definition, this is nothing but the path of the sun around the earth as it orbits around the earth, and the sun does this one orbit, as we all know, in 365 days. And interestingly, this is how it is. All the other planets also are orbiting pretty much close to the ecliptic. They'll go a little bit this side, a little bit that side, but they're almost all close to the ecliptic. In 3-dimensional space, they will all be on the same plane. The 0 degrees on the ecliptic is nothing but the position where the sun will be on March 21st, the vernal equinox. 180 degrees is where the sun will be in the autumnal equinox. And that's where it is getting. As we are heading close to September 2nd, it is here. By September 21st, 22nd, it will reach 180 degrees. And equinoxes are the points in time when on the equator, day and night are equal. And then here are the solstices, 90 and 270. This is March 21st. This is around June 21st. This is September 21st, 22nd, 23rd, somewhere around that. And this is around December 21st to 23rd time period. This is the ecliptic on which all the planets orbit. And we will keep seeing this model again and again and again in all the animations going forward. So this is the geocentric model of the solar system. And this brings me to the end of this animation. Thank you for watching.
Welcome back to the terrestrial plane of nature. So you saw the stellarium animation, and you now understood everything about the geocentric model of the solar system. In the next episode of this serial, I will take up Chandramana, And specifically I will try to explain the calendric elements of Krishna Paksha, Shukla Paksha and Chandramasa. And in subsequent episodes we will move on to Chandravarsha, which is made up of 12 Chandramasas, and the one after that I will get down to the very intriguing concept of Tithi. Many people say Tithi is a lunar day, but that is such an inadequate statement. Yeah? I mean, a Tithi approximately is like a day because it comes close to 24 hours, not exactly, but somewhere it's there in the ballpark. But to call it a day is completely wrong. It's much more interesting, much more intriguing, and it is much more important to us because a lot of our Hindu festivals, Hindu traditions are based on Tithi. But anyway, those are for the subsequent episodes of this series. And as far as this episode is concerned, it's time to close this episode. I hope you liked what I have shown you in this episode. There is lots more to come to dig deeper into the Hindu calendar, and I hope you will stay with me on this journey. You will watch all the episodes as I make the best effort I can to convey my knowledge of the astronomy behind the Hindu calendar to you. So until the next episode, I will close this one. I look forward to seeing you all in the next episode. Take care then, and bye-bye.